Okay, guys. In this video clip, I'll show you what is the error surface of the linear node. In the previous video clip, I think you already know that what is the linear one and how can we calculate the error. But in this video clip, I just want to show you the surface of the linear node. At first, in this collab, it is the one that I already written, and I just want to show you, and I want you to focus on the values, not the way that we write the program. So I decided to use the one that I've already written. So at first, uh, for example, if we have a node, like in the previous video, for example, if we have some specific values that we need, like we have the linear of 2.4 times x minus 1.7. This is the solution that we want. uh, the idea is quite simple. I plot this one as a line, so you can see that we have one line here. A moment. Okay, so we have one line here. Okay, and we have I will train with just only 4 data. That is the XVV1, 4, 3, and sorry, 1, 3, 5, and 8. And y can be calculated using the same equation. So we will have the actual y, the one that we want, this one, and I plot it using the red one. This is the blue line is the line of the linear equation, and the red one is the data, the training data that is on the line. It's on the line. So and this is the part that this is the error of each data. Okay, for example, if we have the weight like this, uh, the weight is W0 is -2, W1 is 2.9. If X is the W1 and Y is the output. Okay, W0 is here in this term, it is -2. Okay, so 2.9 is W1 and -2 is W0. So it's a little bit different from the one that we want, right? So the one that we want, W1 is 2.4, W0 is -1.7. So you can see that we will have some error here. The error from the green plus to the red one. The red one is the actual data on the line, but the green one is the one that you can calculate from this equation. Like you can imagine that this one is like some values that cause some error. So we can find the error by using this distance, square of the distance. So sorry, square of the difference between the green and the red one, and I try to sum it together, and then I plot the error because we have 4 trained data, right? We have 4 trained data, so we can find the error of all 4 training data using the W times X1 plus W0, and this is the actual of the Y values. Okay, so uh, now the x is the blue. The x will be the values of the blue. The values that like an input of W1. X will be x. You can imagine that in this case, if you match our equation, x will be x1. X will be x1, and this one is the output. Y is W1x1 plus W0. Okay, so we will find the difference and take square So this one is the error of each data, and we sum it together in z, and we plot the error, total error of z. So this one is the result. The point that is the actual data that is for 1.7 and 2.4. At this point, it is the lowest data. So at this point here, it is the lowest data, but the error from here to here is like very close to the lowest point. The lowest point is 0, right? But from here to here is like not so different. It's like 0 point something, but so we cannot show it like the if we want to show it, it is a little bit difficult because it is too like just 0 0.1, 0 0.2 something, or 0 0.03 something like that. So you can see this is the part that is like can cause the error that is like very low here, but it is not 0, but it's very close to 0. So but the one that we want is like we want something that is the solution is here. So this is the error surface, and I have something in the sigmoid one also. This one I use the AND table that got 0 0 0, and only 1 and 1 will be the positive one, but for 0 1 0 0 0 0 1 1 0, they are all negative. So guys, the one that I want you to see is we will have some place like this, someplace like this, the one that is the lowest point that we need. So the way that we try to train is if we have some weight vector here, we will try to make it step down, and try to adjust this weight until it reach the lowest point. And you can see that there can be many local maximum and local minimum, sorry. So we try to make it like to reach the global minimum, but maybe in some case we cannot, because it try to trace down this slope, same as this one. So it try to trace down the slope until it reach the lowest point. Okay, so I'll tell you how can we find some values, some equation to train the linear node. And of course, the sigmoid node is they are same. Okay, so see you in the next video clip.